So I'm again very good afternoon, everyone. So today I want to present about the quality assurance and quality control in engineering technology. This is our presentation. Then my group is consisting of my friend Vigintiran Harikrishnan, and our presentation is about control chart for attributes, quality control, and quality assurance. The first, the content of the list is will cover on introduction, quality control and quality assurance. What is quality control and quality assurance? Assurance for sure. Control chart for attributes. Principle of statistical process control (SPC). Important of the control chart application and also for the conclusion. So for the first, we need to know what is about the quality control and quality assurance. So when we are talking about the quality control, that is the monitoring and the controlling processes to meet set specification throughout the corrective action. And for the quality assurance is the systematic approach to ensure product and the service meet the quality standard and customer expectation. And next is about what is the different when we come to the simple way, what is the different about the quality control and also quality assurance. The focus on the quality control is about the product oriented, but in the quality assurance it's about the process oriented. And the objective for the quality control is to detect and fix the defects. And for the quality assurance, we want to prevent the defect. And the time frame for the quality control is after the production, and for the quality assurance is during the development and production. And the second is control chart for the attributes. So control chart are the statistical tools used to monitor and control process variability over the time. So we have the three type of the control chart for the attributes. The first is about the pie chart, that is the monitor and proposition of the defect item in a sample. And the next is pie bar chart display the average proposition of the defect across the multiple sample. And the third is about the C chart, that is the track the number of defect per unit. And the next is we want to learn about the statistical process control, that is SPC. First, we need to know what is SPC. So SPC, in the short form we say SPC is a quality management tool that use statistical method the first to monitor, to control, and to improve the processes. And for sure, the goal for the SPC is to reduce variability in processes to ensure the consistent and the predictable output. And next, what is the core principle of the SPC? First, we want to understand the process behavior. So we know the differentiating between the common causes inherent to the process and special causes unexpected variation. And then the second is about the continuous monitoring, regular tracking of key metrics to identify trends, shift, or out of control condition. And the third, for sure, is corrective action, taking timely action based on the data inset to maintain the process stability. And the next is about the role of the SPC, role of the control chart in SPC. So what is the relation, the main relation we want to know about the control chart in the SPC? So the control chart serves as the foundation of the SPC by visualizing the process data and identifying the deviation from normal behavior. Second, enable early detection issue, preventing defect before they occur. And the third is provide a historical record of process performance for long-term improvement. And this is the benefit of using the SPC. The first, we want to improve the quality. So improve quality, that it will reduce the defect rate by maintaining tire control over the process. And the second, to increase the efficiency. The efficiency is increased. So minimize process downtime and waste. And the third, data-driven decision and hence decision making with objective insight into a process performance. And the fourth is customer satisfaction. That is a consistent quality lead to higher trust and stratification. So that is my part for the presentation. Thank you.
Well, my name is Yugen Tren and will be explain about importance of controls charts. So firstly, detect process deviation. It's identify when a process is out of control or trending toward instability. Next is facilitate decision making. It provide visual insight into a process performance, aiding timely interventions. Third is ensure consistency by support both quality control and quality assurance in maintaining consistent product quality over time. So now we see a chart interpretation for P chart, which is proportion defective. The purpose is the P charts monitor a proportional of defective non-conforming items in a sample. It is often used when data involves pass or fail criteria or binary outcomes, such as defective versus non-defective. As we see in the chart, the interpretation points between UCL and LCS indicate a stable process. Next, points outside the suggest the process may be out of control due to special Gaussian variation. The third is the consistent trends or pattern. As you see in 7 points increasing or decreasing may also indicate a instability. Next is NP chart for number of non-conforming items. So the purpose of NP charts monitor the count of defective items, not the proportion. So I see this chart is prepared when sample size is n remains constant. So as you see in the graph, the interpretation points between limits indicate a stable process, and points outside the limits or patterns suggest the process may be need investigation. The third chart is C charts, count of defects. The purpose of this chart is to monitor the number of defective non-conformities per unit. It is used when multiple defects can occur in single unit. In this interpretation graph, we see the points within limits indicate a consistent process. The points above the UCS suggest an increase in defect occurrence and corrective action is required. As we see, LCL below zero is set to zero as defect cannot be negative. So next will be application and differences. So in aspect of type of data, sample size and example use. For P chart is a proportion defective and its size can vary. An example the use is proportion of defective widgets. For NP chart, count of defective items and sample size must be remain constant. And the example they use are number of defective items per batch. For C chart, the type of data count of defective non-conformities and sample size is not applicable. And example use are number of scratches on car panel. So next is control charts serve as a powerful tool for enhancing both QA and QC frameworks by systematically monitoring quality attributes and process behavior. They provide actionable insight to maintain and improve quality standards. In QC, control chart detect deviation in real time and enabling time correctivity action to minimize defects. In QA, they help in refining process by analyzing long-term trends and fostering a culture of continuous. So for improved integrity control chart effectively requires a proper training for personnel to interpret chart, routine data collection, and analysis to ensure the chart remain relevant. For collaboration between QA and QC teams to use insight from control chart for strategy improvements. So finally, conclusion, the control chart are the indispensable tools in achieving consistent quality and fostering a commitment to excellence in manufacturing and production process. Their integration into a QA and QC ensure not only compliance with the standard but also a competitive edge through superior product quality. That's all it from us. Thank you.